Let us answer intermolecular forces, liquids and solids, lesson 1 quiz, and it consists of 74 points. Identify the different states of matter and explain each state. So, hindi ko na-explain si solid, liquid, and gas kasi kung tinignan ninyo yung lesson natin, nandun lang itong figure 1.1b, molecular model of solid, liquid, gas, and plasma. But, Bose-Einstein condensates. It is a group of atoms cooled to within a hair of absolute zero. When they reach that temperature, the atoms are hardly moving relative to each other. They have almost no free energy to do so. At that point, the atoms begin to clump together and enter the same energy states. They become identical from a physical point of view, and the whole group starts behaving as though it were a single atom. So, yan siya si Bose-Einstein condensates. The lesson number 2, explain in terms of intermolecular forces of attraction why A. The ethanol has a higher boiling point than ethane. The intermolecular force of attraction in ethane is London dispersion force and is a weakest intermolecular force compared to the ethanol. That is a dipole-dipole force. The strongest the IMFA, the higher the energy needed to break the molecules of the substance apart. Higher energy needs means the higher boiling point, vapor pressure, and melting point of the substance is. Letter B, iodine has a lower melting point than sodium iodide. The intermolecular force of attraction in iodine is London dispersion force and is the weakest intermolecular force compared to the sodium iodide, that is an ion dipole force. So the weakest, the IMFA, the lower the energy needed to break the molecules of the substance apart. Lower energy needed means the lower boiling point, vapor pressure, and melting point of the substance is. Kaya may mga sagot dito na binigyan ko pa rin ng 2 points kasi nandun yung keyword na London dispersion force and dipole-dipole force. 1 point naman sa mga nag-explain lang na parang twisted lang yung question. So, dito rin sa letter B, nandun yung keyword na London dispersion force and also the ion dipole force. Kasi again, you need to understand the question. Sabi is explain in terms of intermolecular forces of attraction. Yun lang naman. So number 3, ito yung marami. Identify the types of intermolecular forces of attraction. May it be London dispersion force, dipole-dipole force, hydrogen bond, ion dipole force that are present in each of the following. And another question is identify the molecular name of each. So, eto, nagbigay ko ng example and then most of you ay tama. And then may iba na sinagot yung anong ibig sabihin ng LDF, DDF, HB, and ion dipole force. Tapos sinabi lang kung anong molecular name ng mga molecules. So, I'm a bit disappointed kasi nagbigay na ako ng example on how you will do it. So, talaga. So, next time, really, you need to understand the question. So, let's proceed. 1 point each. This is ethane, and it experiences a London dispersion force. Bakit? Ito si ethane, molecule composition ethane. Kung maalala nyo sa General Chemistry 1 ninyo, nandun yung octet rule natin. Kung saan, yung atom or yung electron ng isang atom is distributed in 4 ways. So, 1, 2, 3, 4, 5, 6, 7, 8. That is the octet rule. Explain ko sa inyo paano i-apply yung octet rule sa ating molecules kaya natin masasabi na polar and non-polar ang isang molecule. So, si carbon, kanina, si carbon, eto siya. By applying electrons from left to right, is si hydrogen, 1 electron lang yan. And then, pagdating kay helium, 2 electrons. Kaya, ang noble gases dito, eto siya, noble gases, ay merong 8 electrons. Kumaga, wala nang pwedeng kumonek sa kanila, kaya sila naging noble kasi wala nang pwedeng kumonek sa kanila, but only their self, kasi meron silang 8 electrons only na puno na. So, si carbon, meron siyang 4 electrons. Meaning, meron pang 4 na kulang sa kanya para maging stable. So, parang, ayan siya. So, si carbon, meron siyang 1, 2, 3, and 4 electrons na kaya pang mapunan ng other elements para maging stable si carbon. So, pwede siyang mag-connect kay another carbon. Ayan siya, ayan, shared na sila. And then si hydrogen, di ba sabi ko, 1 electron lang si hydrogen. Kumbaga, loyal si hydrogen. Isang carbon lang or isang element lang ang pwede niyang kabitan. And eto siya, hydrogen, hydrogen. So, stable na si carbon dito dahil na satisfy yung octet rule. Balik tayo sa ito. Octet rule is hanggang 8 electrons lang. So, magdodraw ako dito. Halimbawa, may ganyan, may bilog. Halimbawa, si neon. 8 electrons kasi 1, 2, 3, 4, 5, 6, 7, 8. And the octet rule applies sa kanya as taught na it is a single atom only. Kasi wala na siyang pwedeng i-share sa iba dahil puno na. Kapag naman si carbon, halimbawa si carbon, yan. Kasi si carbon, 4 lang. 4, 1, 2, 3, and 4 electrons. So, the octet rule is 8 electrons for it to become stable. So, pwede pa siyang mag-connect sa another element, kahit anong element, para maging stable si carbon. Kaya, ayan. Ito siya, masasabi natin na non-polar si carbon kasi pag sinabing non-polar, equally shared yung kanyang electrons. Okay? Kumbaga si carbon, nagbe-bear siya positively, and then si hydrogen, nagbe-bear siya negatively. They equal each other, kaya siya non-polar. So, London dispersion force, and this is ethane. Letter B, si nitrogen. Ito yung itsura ni nitrogen kapag nasa octet rule siya. So, balikan natin si nitrogen dito. Nitrogen is 5 electrons. So, nitrogen. Meron siyang 1, 2, 3, 4, and 5. Meaning, may 3 pwedeng mag-connect pa sa kanya. Okay? 3. So, pwede rin siyang mag-connect sa sarili niya kasi same. Ayan. Kaya, nitrogen gas is a non-polar molecule kasi equal distributed yung kanyang electrons. So, this is a London dispersion force and the element is nitrogen. Next is carbon dioxide. Ito, masasabi nyo, ano ba siya? Polar or non-polar? So, ito yung molecular structure ni carbon dioxide. Dito pa lang masasabi mo na equally distributed yung power ni carbon at ni oxygen sa bawat isa. Paano mo nasabing equally distributed? Kasi, ito siya, si oxygen is meron siyang free electrons na 4, and then connected siya sa carbon, double-sided, and ayun na, hati si carbon equally. Kaya siya non-polar element. Explain ko si oxygen. Oxygen has 6 electrons. Kaya siya merong apat na free electrons is because 6 electrons na yan is 1, 2, 3, 4, 5, 6. So, ito yung free electrons ni oxygen and free electrons ni oxygen. Dalawang element na lang ang pwedeng mag-connect sa kanya para maging stable si oxygen. So, carbon dioxide experiences a London dispersion force. And so, letter D, potassium bromide. Potassium is an ion. It is a cation, metal. And bromine is an halogen. A halogen, okay. Balik tayo sa periodic table natin. Si potassium, ayan. Meron siyang one electron only. Okay? And then si bromine. Ito, si bromine. Meron siyang 7 electrons. So, pag i-draw natin si bromine, or babalik tayo sa kabila, si bromine is 1, 2, 3, 4, 5, 6, 7. Okay? So, meron siyang excess, or meron siyang free electron na kaya niya mag-connect into one element only. So, si potassium ay merong 1 electron na pwede niyang i-share kay bromine. Kaya, it is a ion dipole force of attraction and the element is potassium bromide. Okay? Next is oxygen difluoride. Maraming nagkakamali dito eh. Yung iba, hindi iba. I mean, maraming sumagot dito is London dispersion force daw. But, it is not a London dispersion force. Instead, it is a polar element. It's a very polar element. Bakit? The more free electrons it has, kita nyo, the more na polar yung ating element. Okay? So, pansin nyo, ito yung molecular structure ng ating oxygen difluoride and hindi siya tulad ng carbon dioxide na linear molecule. Ito siya is bent molecule. Meaning, hindi equally distributed yung kanyang electrons sa individual fluorine. So, kaya siya polar element and this is a dipole-dipole forces of attraction. Letter F. Si methanol. Merong iba sumagot methanol. Pero to tell you it is methanol. Okay? Also known as formaldehyde. Si methanol is a dipole-dipole force of attraction kasi ito yung molecular structure niya. Kita nyo pa lang na si carbon is not fully distributed kay hydrogen and hydrogen. Instead, parang na-pull ni oxygen lahat yung electronegativity ng ating molecule. Kaya ito ay polar molecule. And kapag polar molecule, it experiences a dipole-dipole forces of attraction. Next is si octane. Ito siya. Octane is a chain or long chains of carbon dioxide na hydrocarbon. So, tawag dito is a hydrocarbon. Si octane is composes only of hydrogen. So, kapag hydrogen bonded ang ating carbon, it is non-polar element or non-polar molecule. So, it only experiences a London dispersion forces of attraction. Next, let's proceed to magnesium oxide. Magnesium and oxygen. So, si magnesium is 2 electrons. Okay? That is why ganito yung itsura niya. Meron siyang 2 electrons na readily available para kay oxygen na mayroong 2 electrons na pwede pang i-fill. So, si magnesium oxide is a ion, dipole force of interaction siya. Kasi si magnesium is a metal element connected kay oxygen. So, ito siya, ito na yung molecular phase ng ating magnesium oxide. Next is si water. Water is a hydrogen bond or also known as dihydrogen monoxide. Meron doon nagsagot London dispersion force and double force. If you are to answer, choose wisely. Kasi isa lang sagot sa isang problema. Parang sa buhay lang ba? Huwag nating i-complicate yung mga sagot sa mga problema na meron tayo. Kasi yung mga sagot sa problema natin, simpleng solution lang naman yan eh. Kailangan lang natin maging practical. So, ayun, hydrogen bond, kasi si hydrogen bond is only applicable kapag connected siya kay nitrogen, oxygen, and fluorine. Okay? So, next, beryllium hydride or beryllium deuteride. Ito ang itsura ni beryllium hydride. So, si beryllium, punta tayo sa periodic table natin. Ito si beryllium. Ayan, 2 electrons. Okay? Si beryllium ay 2 electrons. And it's dahil connected siya sa hydrogen, so it is only experiencing a London dispersion forces of attraction kasi ito ay non-polar molecule. Okay? Next is si ammonia. Ito, marami akong napansin sagot dito, azane. No. Ammonia is very different from azane. Kasi ibang molecule or iba ata si azane. As far as I know, iba si azane. Iba rin si ammonia. So, si ammonia is a hydrogen bond molecule. It experiences a hydrogen bond. Kasi nga, hydrogen bond only applies to nitrogen, oxygen, and fluorine. Okay? Lastly, si diamond. Ito, bonus ko to sa inyo ha. Kasi si diamond is a diamond, a carbon compound only. It is a non-polar covalent bond compound. Wala siyang intermolecular forces of attraction, but meron siyang intermolecular bonds. Ang bond na meron siya is non-polar covalent. Okay. So, bonus to siya sa inyo. Next, number 4, write in sequence or order from less viscosity to high viscosity. Ito siya is nasa figure 1.11, illustrations of viscosity of some fluids. So, dito ko talaga napansin na yung iba hindi nagbabasa. Bakit? Ito, sagot dito is nandoon na sa lesson ninyo, pero meron pa rin mali ang sagot. Water, milk, oil, light syrup, tapos inuna chocolate syrup, then heavy syrup. Ayan naman klaro naman eh. Kung nagbabasa lang talaga kayo, madali lang talaga ang sagot sa mga problema natin. Okay, next is cite 5 examples of crystalline solids and 5 examples of amorphous solids. Lahat kayo, actually, tama. Nga lang, may iba doon, merong wood sa crystalline solid examples niya. Meron ding merong soil. Ayun. So, crystalline solid samples is may it be ionic, metallic, covalent, or molecular. And yung amorphous solids is labas doon sa ionic, metallic, covalent, molecular. Ito siya, glass, rubber, plastic, wax, crayons, gel, cotton sponge, clay, chalk, wood, marami pang iba. So, ayun lang siya, number 6. Okay.
Let us answer number 6. Using the phase diagram for CO2, Describe the phase changes that will occur if carbon dioxide at 8 atm and 60 degrees Celsius is heated to 100 degrees Celsius, keeping the pressure constant. Let us see the phase diagram of carbon dioxide here. In the y-axis, that is the pressure at 1 atm. This is 1 atm and this is 10 atm. So in between 1 and 10, we can estimate where is the 8 atm here. 8 atm. This one. So if we draw a horizontal line, this red line here, keeping the pressure constant daw. So keeping the pressure constant, we add temperature increments. So if we go to the right, the temperature also rises. As you can see in the x-axis here, the temperature is from negative 40 degrees Celsius up to 100 degrees Celsius for the carbon dioxide. So by keeping the pressure constant and if we go to the right, also we can increase the temperature of the carbon dioxide by going to the right. Ang sabi is 60 degrees Celsius heated to 100 degrees Celsius. Where is 60 degrees Celsius? Here, diba? So, by drawing a vertical line up, mga nandito yan siya. And this one is a gas phase. Okay? This one is a gas phase. If we further add heat to the system or to the carbon dioxide molecule at 8 atm, we can go further up to 100 degrees Celsius, and that is in here, by drawing a vertical line upward and converging that into the horizontal line, which is the 8 atm. We can come up into this point here, and that is also in the gas phase. The answer for this question is carbon dioxide is from the gaseous phase going to another gaseous phase. So next is this question here. Carbon dioxide maintained at negative 20 degrees Celsius, which is this one, is increased from 1 atm to 10 atm. What is the phase of the carbon dioxide? So again, negative 20 degrees Celsius is in here. If we draw a vertical line up, we can increase the pressure going from 0.001 up to 0.01, 0.1, up to 1 atm. And by adding additional pressure up to 10 atm. So here, the phase of the carbon dioxide is in gaseous form. Also, by adding a pressure to 10 atm, the phase of the carbon dioxide is somewhat malapit na sa liquid and gas form. Okay, so the answer is carbon dioxide is from gas phase to the phase where the gas can become liquid.
Nakakatuwa pa rin kasi hindi ko man ito, late ko man to na-explain sa inyo, pero there are some of you na nakuha talaga yung sagot dito sa 6A and B. Marami-rami yun. Meron din naman hindi nakakuha and then unang tingin ko pa lang parang gets ko na copy-paste lang. Pero next time, Siguro naman kung magka-copy-paste na lang din kayo ng assignments, mas matutuwa ako kung tama. Okay, let's proceed to number 7.
Let's answer this question. The vapor pressure of water is 1 atm at 373 Kelvin, and the enthalpy of vaporization is 40.7 kilojoule per mole. Estimate the vapor pressure at temperature 80 degrees Celsius and 110 degrees Celsius respectively. So, we have given tayo at first condition, vapor pressure ng water at 1 atm, and also the temperature of water at 373 Kelvin. That is 100 degrees Celsius. So, mag-expect tayo na vapor pressure of water at 1 atm ay merong temperature na 100 degrees Celsius. This is the boiling point of water at 1 atm. Ibig sabihin, pag nag-boiling tubig within the sea level na may 1 atm pressure, the vapor pressure ng water will equilibrate to the pressure of the surrounding, which is 1 atm at sea level. So, at 100 degrees Celsius, that is the boiling point of the water. At that temperature, mag-i-equilibrate yung vapor pressure ng tubig sa pressure na meron tayo sa environment or atmosphere. Atmospheric pressure is also 1 atm. Okay. Also, given tayo ng heat of vaporization, that is heat of vaporization of water. Meron tayo kung nasa lesson 1 ko yung table 1.1. Pero dito sa question given na siya as delta HV or heat of vaporization ng water is 40.7 kilojoule per mole. And we need to convert it into joules only. 1 kilojoule is equals to 1,000 joules. Cancel this one and cancel this one. We will be having 40,700 joules per mole. And the R, which is the universal gas constant, 8.3145 joules per mole K. We need to memorize this one when we solve water or ideal gases. Okay. Next is the 80 degrees Celsius and the 110 degrees Celsius condition. And ibig sabihin sa condition 2, dalawa rin yung hinahanap. Kasi dalawa yung given. 80 degrees Celsius and 110 degrees Celsius respectively. So, T2, 80 degrees Celsius, convert that into Kelvin, 273 is equals to 353 Kelvin. And another condition is at 110 degrees Celsius, you add 273 to convert that into Kelvin, and that is equivalent to 383 Kelvin. We will now use the Clausius-Clapeyron equation, which is this one, given sa inyong handout. We have equation 1.1 and 1.2. These two equations are just the same. It's just that from this relation, we can come up with this equation. by doing mathematical solution or mathematical solving. So you only need to use this equation 1.1. So P2, the first given here ng P2, we need P1 or diretso na 180 m. Diba? P1 natin is 180 m times E. That is exponential. E to the power of heat of vaporization, which is 40,700 joules per mole, over the R, ideal gas constant, 8.3145 joules per mole Kelvin, times 1 over the T2, which is 353 Kelvin, minus 1 over T1, 373 Kelvin. Ito, P1, yung 180 m kanina, and T1, which is the 373 Kelvin. By solving this, we need to have a scientific calculator. In the future, if you wanted to proceed in the engineering courses or in any course na maraming calculation, you really need to have a scientific calculator because this exponential here is only available on scientific calculators. If we solve that in calculator, so we only need to type the 1 the okay. We only need to type the 1 here, then times E, then minus 40,700 over 8.314. Open and close parentheses talaga yan because 1 over 353 minus 1 over 373 is just this equation. And we will multiply that to this equation. Okay. Or to these numbers. So the P2 here is equals to 0.474 ATM. If we convert that into torr, 1 ATM is equals to 760 torr. Torr is also millimeter mercury. Same lang yan sila. And that is equals to 361 torr. So, napansin nyo, at condition 80 degrees Celsius, and that is and in that temperature daw, yung vapor pressure ng water is 0.7474 atm only. So, we are expecting na this vapor pressure is equivalent to the pressure ng ating atmospheric condition, which is sa yung nakapaligid or yung the condition kung saan yung tubig na yun present. Probably that is common sa mga uphill lands kung saan itong sea level is 180 m at kumukulo yung tubig at 100 degrees Celsius. Pag kumulo yung tubig, ibig sabihin, kapareho na ng vapor pressure ng tubig yung pressure ng kanyang paligid. So, pag nandito siya sa taas, if we go uphill, the pressure also decreases. Okay? Kasi yung gravity natin sa baba, di ba? So, as you go up, you will be malayo ka sa gravity and pressure in that area is also less. So, we will expect na halimbawa 0.47 atm at In temperature 80 degrees Celsius, kumukulo na yung tubig dun sa area na yon na merong 0.474 atm. Kasi nga, di ba sabi ko, if kukulo yung tubig at that temperature, ibig sabihin, equivalent niya yung pressure ng vapor ng tubig sa pressure ng atmosphere or pressure ng lugar na yon. Okay? It is all about the intermolecular forces of attraction na meron sa tubig. The more you go uphill or the more na lesser pressure, the less also yung interaction ng molecules within that um, water. Kaya mas madali na lang siyang mag-escape kapag in-applyan mo siya ng energy or heat. The next condition is 110 degrees Celsius, diba? So, P2 is equals to 1 atm times exponential, again, 40,700 joules per mole over 8.314 joule per mole Kelvin. And multiply by 383 Kelvin. Ito siya, 110 degrees Celsius na yun. Minus 1 over 373 Kelvin. And it will give us a expectation mo na yung vapor pressure kapag lumagpas ng 100 degrees Celsius, expect mo na malaki rin yung pressure, yung vapor pressure niya will corresponding to that temperature. And if we calculate that, we will have 1.41 atm. Okay? And times 760 torr per 1 atm. Cancel. That is 1,070 torr. So, napansin nyo, kapag mataas yung pressure, yung vapor pressure ng tubig, tataas rin yung temperature kung kailan siya magbo-boil. Okay? So, yung lesson na to is all about the intermolecular forces of attraction ng molecules sa tubig. If tataas ka, yung pressure mo is less. Vapor pressure vapor pressure ng tubig. Vapor pressure ng tubig. And also, yung temperature kung kailan siya kukulo is also less. Sea level. So, halimbawa, hindi siya sea, okay? Lupa siya, lupa. Pero ka-level niya yung dagat. Okay. So, halimbawa, may kuweba, bababa ka, and nagbakulo ka ng tubig doon. You need to expect na yung tubig doon is kukulo lamang kapag mataas yung temperature. Kasi, mataas yung pressure dyan. Okay?
Yun lang. Thank you. And isa pa, sa pag-intindi nyo sa question, nakasulat kasi din estimate the vapor pressure at temperature 80 degrees Celsius and 110 degrees Celsius respectively. Pag sinabi ni respectively, similar siya sa word na individually. Ibig sabihin, you are estimating vapor pressure at 80 degrees Celsius daw, and another na 110 degrees Celsius with the same conditions. Itong nasa taas na conditions. So, ganyan din sa exam ninyo in the future. Kung halimbawa magta-take kayo ng SASE or kuan, you really need to understand the question first. So, next time, pag nabasa nyo yung word na respectively, ibig sabihin yan is individually. Yun lang. Good luck